What I want to do now is to consider the following number, 6 divided by the square root of 2. Now, some people when they're looking at this might think that they've simplified this into simplest form because the square root of 2 can't be simplified any further down and the square root of 2 can't divide perfectly into 6. However, it's customary that when we're simplifying surds and presenting them as a final answer in simplest form, that we rewrite these without presenting the surd on the denominator. So we somehow need to manipulate this fraction here so we don't have a surd on the denominator, but to keep the value of this fraction the same. So what that essentially means is we need to somehow manipulate this by only multiplying by 1 or dividing by 1, because if we do anything else, that will change the value of this fraction. So let's start by considering what would we need to multiply this denominator here by to, in essence, remove the fraction that we've got on the bottom. And the easiest value that we could multiply this denominator by would be the square root of 2. And the square root of 2 times the square root of 2, so timesing itself, would equal 2. And that would in essence remove the surd from the denominator that we've got here. However, if we only multiply the denominator by this root 2, we're in essence multiplying by 1 divided by the square root of 2, which isn't equal to 1. So it would be actually changing the value of this fraction that we have here. So what we actually need to do is to multiply the top by the square root of 2 as well. And when we do this, we're multiplying by the square root of 2 divided by the square root of 2, which is equal to 1. So this value here is equal to 1. So it's not actually changing the value of our fraction here. Now when we do this, we need to multiply the numerators together and the denominators together. So when we multiply the numerators together, we'll be left with 6 root 2. And multiplying the denominators together, as we discussed before, will equal 2. And what we now have is a fraction that's the same value as the original fraction, except we've removed the surd from the denominator. Now, once we've removed it, we do have to check to see whether we can simplify this further down. In this case, 2 does divide perfectly into 6. So this is the same as saying 3 root 2, because 2 divides into 6 3 times. Now, when we've got this special situation where we've got the surd as our denominator, and it's only that surd, we can generalize a rule that's as follows. So what we can say in general is for any fraction that has the form of some kind of value as our numerator, all divided by the square root of a, so just that single surd, we can remove the surd from the denominator by multiplying by the square root of a divided by the square root of a. Remembering that we can't actually multiply by anything else other than 1, otherwise we change the original value of the fraction. In this way, we can keep the original value of the fraction, but we can rewrite that value without the denominator being a surd. Now this is all well and good if we have a fraction that has the format of a number divided by the square root of a. But what if we had something that was a little bit different? What if we had 9 divided by 5 plus the square root of 2? Now if we applied the same logic before, we would multiply by the square root of 2 divided by the square root of 2. Now if we multiplied this denominator by the square root of 2, we would actually have to multiply each term by the square root of 2. And that wouldn't work for us because 5 times the square root of 2 is 5 root 2, and it would still leave a surd on the denominator. So we need a different strategy here. And the strategy that we actually use comes from a skill that we've learned previously in algebra, specifically when we're expanding and factorizing quadratics. And that's using our rule from the difference of two squares. At the moment, we've got 5 plus the square root of 2. If we multiplied by its difference of two squares, we would actually successfully remove the surd from the denominator. So what we would need to multiply by is 5 subtract the square root of 2 as our denominator. But we can't change the value of this fraction, so we must ensure that we're only multiplying by 1. So that means we also have to multiply our numerators with 5 subtract the square root of 2. Now when we do something like this, we apply the same sort of logic that we did earlier by multiplying the numerators together, which will result with 9 times 5 subtract the square root of 2. And we would need to multiply the denominators together, which would leave us with 5 plus the square root of 2, all multiplied by 5 subtract the square root of 2. And as you can see here, we've now got the difference of 2 squares as our denominator. So when we simplify this, let's focus on the denominator to begin with. The difference of 2 squares rule says that when we've got this situation, this special situation, this is equal to the a value, so our 5 value squared, so it's 5 squared, subtract our b value, which is our root 2 value, so the square root of 2 squared. But we also need to expand this numerator. So we do that by multiplying the 9 with each term inside of our brackets. So 9 times 5 is 45. And we'll have subtraction here, and 9 times root 2 will be 9 root 2. Now, obviously we haven't actually removed the surd from the denominator here yet because we still have to simplify this. So as we go to simplify this, we'll just leave the numerator as 45, subtract 9 root 2, because that can't simplify any further yet. But we can simplify this denominator here, so 5 squared will be 25, and we'll be subtracting the square root of 2 squared, which will be 2. Now, we can simplify this denominator even further by keeping the numerator the same, because we can't simplify that, so subtract 9 root 2, but 25 subtract 2 is 23. So what we've now successfully done, as you can see here, is we've removed the surd from our denominator. Now, at this point, this can't simplify any further down. So this is now in our simplest form. Now we can use this difference of 2 squares sort of understanding with any kind of fraction that we have here that has this sort of form. So when we go to generalize this, we can say that for any fraction of the form a number all divided by a plus the square root of b, we can remove the surd from the denominator by multiplying by the value of a subtract square root of b, all divided by a subtract the square root of b. Now you'll notice here once again that we're multiplying by a value divided by itself, which is equal to 1. So doing this will not change the original value of the fraction.